Hi everybody, my name is Joey and I'm the Perfect Score Tutor. I've gotten perfect scores on both the SAT and ACT. However, I'm here today with a copy of the 2024 free response questions to the Calculus AB exam. I'll be breaking down the free response questions into detail so you can predict how you did on this exam. Or if you're looking at this from a future test date, you can use this walkthrough to study for your upcoming calc exam. Question 5 looks like an implicit differentiation / differential equations question. They give you the original function and then they also give you dy dx, which is also known as the slope of the tangent line. So part A says there's a point on the curve near 2, 4 with x coordinate 3. Use a tangent line to the curve at 2, 4 to approximate the y coordinate of this point. Well, this is the slope of the tangent line, so all we need to do is plug in this point in the tangent line. So how do we show our work? We just say dy dx, and then we can draw this long vertical bar to indicate that we're plugging in the point 2, 4. And then when we plug in the point 2, 4, we get negative 2 times 2 over 3 plus 4 times 4. So this is equal to negative 4 over 19. So I think students get confused when they see multiple letters here, but all you got to do is plug in the point and then just remember that dy dx represents your slope. And now let's plug it into our tangent line equation. So it's going to be y minus the y point is equal to our slope times our x minus our x point. So that's our tangent line. And now it says it has the x coordinate of 3, and so we want to find that point. So we're going to plug in 3 for our x. So y minus 4 is equal to negative 4/19 times 3 minus 2. 3 minus 2 is just 1. So y is just equal to 4 minus 4 over 19. Remember, on the non-calculator section, you don't need to simplify this if you don't want to. But for my sake, what is 4 times 19? 40, 36, 76/19 minus 4/19. So then that's going to equal 72/19. 19 is a prime number, so this is not going to simplify. So the coordinate point that we're looking for is 3, 72 over 19. Part B asks us if the line y equals 1, a horizontal line, is tangent to the curve, and give a reason for your answer. So remember that horizontal lines have a slope of 0. Well, where does this give you a slope of 0? It's only when the numerator is 0, right? So when the numerator is 0 of dy dx, you get a horizontal tangent line. And then when the denominator is equal to 0, that's when you get a vertical tangent line. So please keep that in mind. When do we get a horizontal tangent line? Well, we get a horizontal tangent line here when x is equal to 0. And so if that's true, we would want to plug 0 back into our original equation. And we plug in 0 there, we get 0 squared plus 3y plus 2y squared is equal to 48. So then this becomes a quadratic equation that we'd have to solve. So it becomes 2y squared plus 3y minus 48. So then here we could try to factor it, but it looks really complicated to try to factor. But we do have a point over here, right? They're saying is y equals 1 tangent to the curve. So that means it would have to pass through the point 0, 1. So for those of you who don't know, this is the graph of an ellipse. You don't need to know that though, so I'm just doing this for an example. So basically, for a line to be tangent and have a horizontal tangent line, let's say this is the line y equals 1, and we know that it has a horizontal tangent line when x is equal to 0, then it would have to pass through the point 0, 1. And right now, if we were to plug in 1 here, 1 would not work into this equation, right? We get 2 plus 3 minus 48. Or we could plug in the point 0, 1 into this original equation and show that it doesn't work either, right? It'd be 0 squared plus 3 times 1 plus 2 times 1 squared is equal to 48. This doesn't work either. So then we could come up with an answer talking about how this point doesn't work into this function. The curve only has a horizontal tangent line when x is equal to 0. For y equals 1 to be a horizontal tangent, the curve would then need to pass through 0, 1. However, that point does not work in the given equation. Therefore, y equals 1 is not tangent to the curve. So for you to get credit in this question, I do think you need to showcase that you know that horizontal tangent lines only occur when x is equal to 0. I think you also need to plug in the point y equals 1 into the equation and see if that works. And you would show that the point 0, 1 doesn't necessarily work in this equation. And then, of course, you need to justify using complete sentences with proper grammar. Now, another way we can think about this question is to work backwards, right? Is the horizontal line y equals 1 tangent to the curve? If it's tangent, that means it touches the curve. So we can plug in the point 1 for y. So it'd be x squared plus 3 plus 2 is equal to 48. And then when we plug that in, we would get x squared is equal to 48 minus 5 is equal to 43. And then x would equal plus or minus rad 43. So then the point of tangency of this ellipse would be root 43, 1. That'd be one of the points. And then negative root 43, 1 also. And then when you plug them into this equation here, you would see that the slope would not equal 0. So let's write a full response for this version of the question. By plugging y equals 1 into the equation, we see the curve crosses through the points root 43, 1 and negative root 43, 1. When we calculate the slope using these points, we get a slope that is not 0. Therefore, y equals 1 is not tangent to the curve. Part C says the curve intersects at this point here, and they want to know if this line is vertical. So like I said in the previous question, you get a vertical tangent line when your denominator is equal to 0. So let's figure out if that works. So 3 plus 4y is equal to 0. And so that would occur when y is equal to negative 3 over 4. Well, that's not going to work then, right? Because it says it should occur at root 48, 0. So then no, it's not at that point. Or another way you could do this is you could plug in the point that they give you into the slope function, right? So dy dx then would equal negative 2 root 48 over 3 plus 4 times 0. So let's go with this one to write the explanation for it then. When we plug the point root 48, 0 into dy dx, we get a slope value that is defined. However, vertical tangent lines only occur when dy dx has the denominator equal to 0. Therefore, the tangent line at root 48, 0 is not vertical. For you to get full credit on this question, you'd have to showcase that you understand that vertical tangent line occurs when the denominator of your slope is equal to 0. And then, of course, you need a full sentence using proper English grammar. Part D says for time t is greater than or equal to 0, we have a particle moving along another curve defined by this equation. At the instant the particle is at the point 4, 2, the y-coordinate of the particle is decreasing at a rate of 2 units per second. So decreasing at a rate would mean dy dt is equal to negative 2. It is decreasing. So we want a negative rate. At that instant, what is the rate of change of the x-coordinate of the particle's position? So they're looking for dx dt. So this is a related rates question. So what we want to do then is we want to take the derivative of this function with respect to time. So here's how I show my work. d dt of y cubed plus 2xy is equal to 24. So then the derivative of y cubed is 3y squared times dy dt. This one we're going to need to use the product rule, so it's going to be the first, I'll call my 2x the first, times the derivative of the second, derivative of y is dy dt, plus the derivative of the second then, so it'd be 2 dx dt times y. And do not forget that when we take the derivative of the integer on the right side, that's equal to 0. So then we have everything we need to plug into this equation. Then we have the point, and then we have the dy dt. So then it's going to be 3 times 2 squared times negative 2 plus 2 times 4 times negative 2 plus 2 times dx dt is the thing that we don't know. And then y is just 2 is equal to 0. So let's move everything over to the right side. So what is this? This is 3 times 4. This is negative 24. And then this is 2, 8, 16. So this is negative 24 minus 16. So then if we added it over to the right side, we get 2 dx dt times another 2 is equal to 24 plus 16. And then we're going to go ahead and divide everything by 4, right? So then dx dt would equal 24 plus 16 is 40 over 4. And typically we want units, so let's see, it'd be 40 over 4 units per second. And that simplifies to 10. So let's predict how the points are going to be distributed for this question. I think for part A, you'd get a point for calculating the slope. You'd get a point for calculating the proper tangent line. And then you'd get a point for calculating the final value. So if you got the slope wrong and still carried it through for the tangent line equation and the approximation, you could still probably get 2 out of 3 points here. So part B is a pretty complicated question. I think you'd get a point for understanding that the horizontal tangent line only occurs when x is equal to 0. And then I think you'd get another point for your explanation, whatever that explanation is, either by plugging the point of horizontal tangency into this equation or plugging y into this equation and calculating some sort of point. So I think this is a 2-point question. That second point is going to be a little bit vague and nebulous. Part C, I think part C is also a 2-point question. I think if you were either going to try to calculate where you have a vertical tangent line, or you plug in the point here to see that it doesn't work in this equation to get a vertical tangent line. Either way, by plugging in this point or calculating a point, you would get a point, and then you get another point for your explanation. So I think this would be a 3-point question. You get a point for doing the derivative here using the product rule, probably 1 point for the product rule, 1 point for the whole derivative, and then 1 point for the final answer. So depending on how generous they are, they might make part C only worth 1 point because it was a little bit complicated. Or if they're really mean, they might make part A worth only 2 out of 3 points. Thanks so much for watching this video. If something was unclear or you need me to break down an explanation even more, feel free to leave a question or comment below.